Okay, we're going to talk about a concept called voltage fault current. Okay, this is a 200 amp panel, single phase, 240/120 single phase. 200 amp panel, probably like many of you have in your home. You either have a 100 or a 200 amp panel in your home. So voltage fault current is a current that will instantaneously go through a circuit when you either have a ground fault or a dead short line to line until the fuse or the breaker ahead of it blows, okay? Downstream of the circuit from your panel will be down toward the receptacles in your, for your TV, your kitchen, outside receptacles, your air conditioner, all your loads. That's downstream from your panel. Upstream will be out there on the pole or on your pad mount transformer where a fuse is on the primary of that transformer that protects all your incoming line up to here, okay? Now, it'll sit there and supply 200 amps all day long, 200 amps, normal load current, 200 amps, 200 amp breaker, 200 amps. But I loosened these up earlier. These are your two main conductors coming in from your transformer, okay? I've got a pair of channel locks here. And let's say the power company's got it killed outside, okay? They got the fuse pulled. We're gonna clamp these together, okay? Now, that's a dead short, okay? We've got your two leads here, if you can see it right here, okay? We got a dead short. Let's say we got them clamped together good. The lineman out there is going to throw that line jack in or put that fuse in on the primary of your transformer. It's going to take about 2 cycles, give or take, for that fuse to blow. 2 cycles when we're on 60 hertz, okay, comes down to, you know, about 0.03 seconds. So 2 to 3 cycles, when that lineman throws that fuse in, during that 2 to 3 cycles, not seconds, cycles, since this is shorted out, the maximum current is going to flow through that wire. For those of you, and most of y'all should have already had circuits too, if you remember figuring out, calculating the impedance of a circuit, the only thing holding this current back is the impedance of the circuit, okay? The impedance of the circuit, which is the inductance of the transformer, the internal resistance of the transformer, and the resistance in the lines. This is 4-aught aluminum, so it's very low resistance on that. So, it's a 200 amp breaker with 200 amp feeders, but whenever they size your transformer for your house, the engineer from Kenergy or OMU, they understand it, they know what they're doing, and they are going to size your transformer so that a maximum of 10,000 amps instantaneous current will flow. So as soon as that lineman throws in that line jack, upwards of 10,000 amps will be going through here for 2 cycles until that fuse blows. If you look at breakers, if you got one laying around the house or whatever, this is a 15 amp breaker. There's 3 ratings on fuses, 3 ratings on breakers. The standard 15 amp. Then it's got a voltage rating, okay? 120/240 tells us the maximum voltage is good for. Then on the side here, it's got 10,000 amps interrupting rating. That 10,000 amps is very important for either a circuit breaker or a fuse, because in the case of a dead short, this little fella here can withstand a 9,000 amp inrush. They call that inrush whenever you have that kind of current. when a motor starts, pulls 6 to 8 times full load current. That's inrush current. Here would be inrush on a fault or fault current. So when you're in industry now, you could never use this. This is for a home. And they size a transformer and your feeders to never exceed 10,000 amps. So this is a residential panel. When you get out in industry on 480 volt breakers and distribution, you're going to have 100 KA, 100,000 amp rated breakers in a lot of cases. Be much higher. You know, if anybody asks you, well, why can't we use a residential panel so much cheaper than an industrial panel? Hey, that's why. Because in industry, you've got what they call a lot stiffer bus. In other words, if you have an 800 amp panel, how much do you think industry is going to draw on it? 800 amps, or as close to it as they can get. They're turning everything on all the time, all the time. So they had to have a lot stiffer bus, a lot bigger feeders, and they're going to run everything all the time or design it to do that. So industry, 100,000 amps. You're going to find other ratings too, 65 KA for some older equipment. But for residential, it's 10 KA. So bolted fault current, when we bolt those feeders together, and then when we turn it on, that bolted fault current is what we're talking about. That instantaneous current for 2 cycles with a fuse. But if you have a breaker upstream, that current's going to be up there at 9,000 amps for 6 to 8 cycles. So 3 times longer, 4 times longer for a breaker than for a fuse. That's why a lot of times you use a fuse instead of breakers. Fuses are faster acting than a lot of your breakers. So, send me any questions you may have, bring them to the lab. Bolted fault current. I hope this helps.